Welcome back, ladies and gentlemen. JLand Bio here. We are going to do our last part of this unit, which is focusing on calculations related to heat change. So we talked a little bit about changes in temperature, changes in kinetic energy when we are changing states of matter or when we are altering the temperature. We're going to actually perform some calculations directly related to heat change in an environment. By the end of this video, hopefully you will be able to understand the concepts and relationship between heat and temperature, and to be able to calculate the change in heat of a chemical, including those with a phase change. So we have some key vocabulary terms for you here today. We are going to focus on temperature, joule, heat, specific heat, enthalpy of fusion, and enthalpy of vaporization. Those are our key vocab terms for this video. So one thing to keep in mind, and we've talked about this previously, is that temperature is a direct measure of kinetic energy. This is different than, say, heat, which is the amount of energy transferred between substances. The SI unit for the heat and energy is the joule. So if you take a look at the gas particles on the right, they have more kinetic energy than those on the left. They are moving faster. By having faster movement, the gas on the right also has a higher temperature. So please keep in mind that temperature is a direct measure of kinetic energy. Now, the ability for energy to transfer from one substance to another depends on the nature of the material, and not just the material itself, but what state of matter it's in. The term specific heat refers to this nature. It's the amount of energy required to raise the temperature of 1 gram of the substance 1 degree Celsius. So the amount of mass and the change in temperature play a role in the amount of energy as well as the state of matter. Intermolecular forces play a role. Lots of things go into this. So keep in mind that the specific heat, and it is a constant value for a substance, is the amount of energy required to raise the temperature of 1 gram of the substance 1 degree Celsius. So how do we perform heat change calculations? Well, this looks like a really complex formula, but if you take a look here, there are 5 variables, okay? I will give you 4 of those 5 variables. You will just have to solve for the one unknown. So it's just a little bit of algebra here. The formula is Q equals MC, and sometimes you may see it as delta T. Delta T just simply refers to the change in temperature. The change in temperature is always the final temperature minus the initial temperature. So all you do is you plug your numbers in and you solve for whatever unknown variable we're looking for here. Q is heat. Totally makes sense, right? Q would be heat. M is mass. C is the specific heat, which is, again, a constant value that I'll give you. Final temperature, and then the initial temperature, which is TF minus TI. So let's look at some practice problems directly related to these calculations. Let's look at number 1. It says, what is the mass of water that can be heated from 25 degrees Celsius to 50 degrees Celsius by the addition of 2,825 joules when the specific heat of water is 4.18? So again, we're going to be using the formula here, Q equals MC delta T, or change in T. Okay? So let's assign some variables here. We know we have our temperatures here. We have heat, and we have the specific heat. So let's assign some variables. So Q is 2,825. My mass is unknown. Okay, again, that's what the question is asking for. The specific heat is 4.18. The final temperature is 50. Remember, that's what we're going from 25 to 50. And the initial temperature is 25. So now all I do with all of these variables is I just plug them into my equation and I solve. So we're going to say that 2,825 equals M, our unknown, multiplied by C, multiplied by 50 minus 25. Okay? So now all we do is we just solve algebraically. So I'm going to simplify a little bit here. I'm going to get 2825 equals M, and I just did the algebra here, so this is 104 So now I just divide both sides by 104.5 to isolate m by itself, and my answer is 27 grams. Okay? That's all there is to that type of problem. Let's do the practice problem on the bottom here. What is the final temperature when 625 grams of water at 75 degrees Celsius loses 79,600 joules? Well, now here's the thing to think about here. We're looking for the final temperature. Okay, that's what the question's asking for. We're given mass, the initial temperature, and the fact that it loses 79,600 joules. So if we're losing heat, then Q is going to be negative. All right, so let's set up this problem. So we're going to have negative 79,600 joules. And again, the reason it is negative is because it says it loses heat. Okay, so Q equals M, mass, is 625. The value for C, because we're still dealing with water, is 4.18. And our change in temperature, we want to know the final temperature, that's unknown. We're going to subtract the initial temperature, which is 75. Okay? So now all we do, again, is algebraically solve for our unknown. So what I'm going to do here is I'm going to take 625 times 4.18. Okay? So this is going to be 2612.5 times my final minus my initial. Okay, still equals the same value there, so I'm going to divide by 2612.5 on both sides. Let's see what we get. So what we get here is minus 30.5 equals TF minus 75. So we add 75 on both sides, and we get our final temperature is 44.5 degrees Celsius. Okay, so again, all this boils down to is just doing a little bit of algebra here. Okay, you get 4 out of the 5 variables, you solve for the one that's unknown. Pretty straightforward. Let's move on to one more type of problem that's a little bit more complicated. So this is where these types of problems can get a little bit hairy, so to speak, is that if there's a phase change in this type of problem, there's actually a separate calculation you do, because there is energy that is required to go from 0 degrees of ice to 0 degrees of liquid water. So there is no temperature change, but there is a phase change. So for example, if I were to go from negative 20 degrees ice to 30 degrees water, I'd have to include this in my calculations. So this is where it gets a little bit iffy, because if there is a phase change, you're going to have to do 3 separate problems. One, we go from ice from negative 30 to 0. Your phase change from 0 of a solid to 0 of a liquid, and another one going from 0 degrees of liquid water to 30 degrees of liquid water. So there'd really be 3 problems there. If you had 2 phase changes, there'd be a total of 5 equations. Okay? Now the equation is represented here, and it's actually a little bit easier to solve. It's Q equals the heat of fusion times the mass, or the heat of vaporization. Heat of fusion is if we are at the solid to liquid phase change, and heat of vaporization if we're at the liquid to gas phase change. All right, so there's really 2 equations here. Let's move forward with one calculation here. All right, let's look at this practice problem. It says, what is the amount of heat required to convert 25 grams of 0 degrees ice to 0 degrees of water? The heat of fusion of water is 334 joules per gram. Well, this one's actually pretty straightforward. So it's asking for the amount of heat required. Notice there is no temperature change, so it is a phase change. We're given mass and our heat of fusion. So all we do is we plug it into our equation. Q equals the heat of fusion times mass. Q equals 334 times 25. Whew, that's a tough one. Plug into your calculator and solve. Q is equal to 8,350. And again, it's Q, so it's measured in joules. All right, so let's look at an equation. All right, let's look at a problem that requires multiple sets of equations here. It says, what is the heat in joules required to convert 25 grams of negative 10 degrees Celsius of ice into 50 degrees Celsius of water? So if we take a look here, we've got quite a few things that are going on. The question wants to know heat in joules. We have 25 grams. We're starting at negative 10 and we're going to 50 degrees. But remember, there is a phase change here. We are going from ice to water. Okay? So that means we're going to need to do 3 equations. The first one, equation number 1. So we're going to have Q equals MC delta T. We're going to start with 25 grams. The specific heat of ice, remember we're starting at negative 10, is 2.09. The final temperature, the last temperature at which we have ice, is 0. And our initial temperature is minus 10. Okay? So now what we've done, that's the amount of heat that's required to get it to 0 degrees Celsius of ice. The next equation is going to be our phase change. Remember, that is a different equation. That's Q equals HF times M. So we're going to have Q. The HF is 334. And our mass, again, is 25 grams. So that is the amount of heat required to go from 0 degrees Celsius of ice into 0 degrees Celsius of water. Our third equation is back to Q equals MC delta T, but now we are in our water state, so we're going to use the specific heat of water. And our temperature change, our final temperature is 50, and our initial is 0. So we're raising the temperature from 0 degrees Celsius of water to 50 degrees Celsius of water. So what you do here is you solve for all 3 Q's, and then you add them all together. All right? So let's complete that part of the problem. So the first one is 522.5 joules. Next one is 8,350 joules. And the last one is 5,225 joules. So then we just add them all up and solve. And our answer is 14,127.5 joules. Okay? So again, you need to make sure you read the question very carefully. If there is a phase change in there, you need to make sure you do all 3 sets of equations. You can't just plug it into one and solve. All right? Take your time with these, read the questions carefully, and do your calculations carefully, and you'll have no problems with these whatsoever. So it's a bit of a longer video, but long story short, the heat change in a substance differs based on the chemical properties of the substance. The specific heat formula solves for changes in heat when there is no phase change. And heat of fusion, heat of vaporization are required to calculate the change in heat during a phase change. Like I said, a lot going on in this video. Take your time with it, perform those calculations slowly and carefully, and you will do just fine. This is JLand Bio. Have a great day, guys. We'll talk to you later. Bye-bye.